Now you need to know the exact values for the sine, cosine and tangent of standard angles. These angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Now if we first create an equilateral triangle, that's a triangle where all three sides are the same length and all three angles inside are the same length, i.e. 60 degrees. Then consider an equilateral triangle of side 2. Now if we draw a perpendicular from the vertex to the base, this creates two congruent right angle triangles. And if we look at one of these right angle triangles, the base length is 1, the hypotenuse is 2, and using Pythagoras Theorem the adjacent will be the square root of 2 squared minus 1 squared, which equals the square root of 3. Now if we look at the triangle labelled hypotenuse, adjacent and opposite with blue writing, we can deduce the following. The sine of 30 degrees, which equals the opposite divided by the hypotenuse, equals 1/2. The cosine of 30 degrees, which equals the adjacent divided by the hypotenuse, equals √3/2. And the tan of 30 degrees, which equals the opposite divided by the adjacent, is 1/√3. But we could of course have labelled this triangle in a different way, using the 60-degree angle. And if we look at the triangle with red writing, this time the sine of 60 degrees equals the opposite divided by the hypotenuse. So here this is √3/2. The cosine of 60 degrees, which is the adjacent divided by the hypotenuse, equals 1/2. And the tan of 60 degrees, which equals the opposite divided by the adjacent, equals √3/1, which reduces to √3. Now, we also need information about a 45-degree angle. So if we draw a right-angled isosceles triangle with a base and height of 1, then by Pythagoras' theorem, the length of the hypotenuse is equal to the square root of 1 squared plus 1 squared, which of course equals the square root of 2. And since this is a right-angled isosceles triangle, the other two angles must add up to 90 degrees and they must be the same size because it is isosceles. So each of the other angles is 45 degrees. So we can choose one of these two angles, and if we look at the triangle with green writing, then the sine of 45 degrees equals opposite over hypotenuse, which equals 1/√2. And if we wish to express this in a rationalised form, we simply multiply 1/√2 by √2/√2. So we can also write the sine of 45 degrees as √2/2. Now the cosine of 45 degrees equals the adjacent divided by the hypotenuse, and that also equals 1/√2. Again, we can write this as √2/2 if we wish. Finally, the tan of 45 degrees equals opposite over adjacent, which equals 1/1, which equals 1. Now if we look at the graphs of sine, cosine and tangent, we can see that the sine of 0 degrees equals 0, the cosine of 0 degrees equals 1, and the tan of 0 degrees equals 0. Now look at 90 degrees. The sine of 90 degrees equals 1, the cosine of 90 degrees equals 0, and actually, if we look at the graph, the tan of 90 degrees is not defined. We could also see this as an equation, because recall that the tan of an angle is equal to the sine of an angle divided by the cosine of an angle, and so the tan of 90 degrees equals the sine of 90 degrees divided by the cosine of 90 degrees, and this equals 1 divided by 0. Now in mathematics we're not allowed to divide by 0. 1/0 is not defined.